And now it's time for
a tiny bite
of knowledge.
It ain't easy being green, being the colors of the leaves.
It might not be easy being green, but what is relatively easy is detecting how green something is. And that comes in the form of NDVI, or Normalized Difference Vegetative Index. So that's what NDVI stands for, but let's break this down. What is a vegetative index even? What is it?
A vegetative index is when we use light, specifically using different bands of light within the electromagnetic spectrum to understand vegetation. So when we think about NDVI, Normalized Difference Vegetative Index, it's an index where we have a ratio and a specific formula that compares near infrared light to red light, and that helps us understand how densely green the plant canopy is. Basically, in dumbed down terms, when our human eyes see green, it is because red light is getting absorbed. And so plants are absorbing red light, green is being reflected. And so when we take into comparison near infrared light and red light, we are able to understand how green and how densely green the plant canopy is across the landscape.
So what does that mean for us? How do we use that number in a practical way?
So chlorophyll strongly absorbs visible light, and plant cell structures on the leaves strongly reflect near infrared light. So NDVI specifically is a way of calculating the amount of light that is being absorbed and used for photosynthesis, and also how much light is reflected. This is important because it's going to help us understand how green and how densely green a plant canopy is across the landscape. For our purposes in agriculture, we're really thinking about where is a field of crop more or less green than other areas. Because this is really an indication of photosynthesis, this can be a great way of thinking about the productivity potential across a landscape. And actually, there's many places and many times where NDVI can actually correlate to yield data. Not always, but many times it does correlate to yield data.
So does that mean a lot of what we use in terms of imagery will extract the NDVI value from that imagery and then use that to build zones?
Absolutely, Jodi. Many times here at GK Technology, we actually use a lot of satellite imagery to help understand the productivity potential of a field across the landscape. It can help us understand where the crop has more potential to photosynthesize and have greater yield potential, productivity potential, and areas of the field where there's less photosynthesis happening and therefore less productivity potential. So from that, when we can take a look at different satellite images over the years, we can understand across a given field where those areas are consistently happening. Where are we consistently seeing greater amounts of NDVI throughout the growing season and lesser NDVI and photosynthesis potential across that field. Once we can figure out where that is happening consistently over a number of years, we can create zone maps that can help us understand where we should be investing in more inputs into areas where the greater production potential is happening and where maybe we should try to manage that input cost so that we have less inputs going into lower productivity areas.
So basically what I hear you saying is we want to find out like where the NDVI value is lowest, consistently the lowest. Those would be what we consider like a low productivity zone, and the areas where the NDVI value is the highest, those are hypothetically and probabilistically our areas of highest productivity. And we want to manage those like those are our highest producing zones or our areas with highest yield potential.
Absolutely. And so we are obviously transitioning this conversation from NDVI to how we're using these in a practical sense for making zones. So Jodi, would you ever use just one NDVI image to create zones from 1 year?
Absolutely not. It is a snapshot in time, and that doesn't necessarily reflect any sort of variance in weather patterns or it may be like a single snapshot is a culmination of conditions that occurred that year, but that doesn't necessarily mean that that's consistent over time. And so, no, I do not use a single image to create zones, and I do not promote that either. Just because what we're trying to do when we're building zones is we're trying to predict variability and predict consistent variability. And so with just one snapshot, you aren't able to really create something that holds up over time.
I couldn't agree with you more, Jodi. You just totally hit the nail on the head with that. And I do the same thing. When I'm looking at imagery over time, I want to find those areas where we are having consistently lower productivity potential and areas of the field where we're having consistently higher productivity potential. And that just is not possible with only one image in 1 year.
Yeah, absolutely. And there's a couple things to just mention about NDVI before we wrap this up. The calculation for NDVI, just the bare bones or textbook version of this, it's going to produce a value that's either from -1 to +1. Whereas if you get closer to 1, that means that it's the highest densely green you could have, whereas the whole -1 would be the most opposite of green you can have. But what I want to make this point of is that in ADMS, if you're an ADMS user and you're extracting NDVI images, what we do in the software is we do multiply that NDVI value by 100, meaning that if you're used to seeing and looking at NDVI values, this -1 to 1 concept is going to sound kind of weird, but that's because we multiply it by 100 to make it easier to remember. In our grand scheme of things, you probably are familiar with looking at values from like negative point something or like very lowly negative to up to like 83 to 90. And so those are kind of like the normal, what we would say, range of NDVI values you might see in ADMS.
And I think in ADMS, when we're looking at our histogram, once you reach right around like 35 or 40 in there, we're starting to think about having, some greenness on the landscape. You're kind of out of the area where green plant matter is starting to dominate that land versus soil or something that's non-vegetative. And it doesn't take very long to get up to that complete saturation. Those numbers that are 80, that's it's really hard to find vegetative indices out there that are different from each other. When I'm looking at imagery and I'm trying to make zones out of that imagery, something that has no vegetative indice to it at all, it's like less than that 30 value, and you can't tell differences on the landscape from a vegetative perspective, that's not very helpful to me when I'm considering vegetative indice data only. But also once I get up into that place where it's completely saturated and I can't see any differences in the green canopy, that's also not the most helpful image to me because I can't tell where those differences are. And a lot of times we'll see the differences in the plant canopy earlier in the growing season, and then there'll be that time when the plant canopy is completely saturated and you just won't be able to tell a whole lot of difference. And then as you start to move more towards senescence, you'll start to see some variability again and perhaps how that plant canopy dries down again. So the images that I find the most difficult to use when it comes to NDVI are where there's absolutely no plant material out there at all, or the images that are absolutely 100% saturated with greenness and I can't tell any difference.
Right. We're trying to use these images to figure out where those consistent differences are. And Sarah and I could talk about this subject for a long time. And in fact, we have. And if you want to hear more too about, how we can choose imagery that helps us get better NDVI data to build those zones, do check our backlog. We do have an episode called Choosing Quality Imagery in season 1. So please check that out. But what I think I've heard today, Sarah, is that maybe it isn't always easy being green, but hopefully with zone management, it's a lot easier to manage those areas that are green and hopefully improve the way that we're managing those less green areas to get them closer to that darker green, the higher NDVI value.
It ain't easy being green, being the colors of the leaves.
Tune in next time for a tiny bite of knowledge from GK Technology, where we have a map
And an app
for that.
I love Kermit the Frog. He makes me so happy.
Let the geeks at GK Technology help you with your agricultural data. Their agronomists know agriculture. When it comes to creating soils and zone maps to maximize yields in your fields, you can trust the people with decades of experience in site-specific agriculture. Everyone at GK Technology has a background in agriculture, so they know what makes a farm run, and they speak your language. The geeks at GK Technology have a map and an app for that.